What the hell do you need to consider when swimming on the East Coast? Today's video, we're going to look at tidal currents. To help explain what this is, I'm out looking for a garden hose. May I borrow your garden hose, please?
I'm a bit too busy.
Okay, thank you.
Look.
Right, we'll keep looking. Now, most people consider the tide to be simply a difference in height of water levels. This cycle takes approximately 6 hours. So, if the tide is out at 9 AM, at 12 o'clock it'll be mid-tide, and at 3 o'clock it'll be high tide. This cycle never, ever times infinity stops. So you need to ask yourself the question, where the hell does all this water come from? So, the moon and the sun interact with the water on the Earth's surface to cause a bulge. This bulge is formed by the gravitational pull of the moon and the sun, which I've left out for simplicity's sake. This bulge then moves around the Earth and forms currents. And given our location on the planet and the land masses that surround us, Ireland is quite drastically affected by these currents. And here is some proof. This is Wicklow Head on an ebbing spring tide. This just shows how extreme these currents can get on our Irish coasts, and now it's time to figure out exactly why this happens. And now I'm really starting to need this garden hose. May I borrow your garden hose?
You may borrow my garden hose.
In the first clip, you'll notice that the water is flowing out of the hose freely. In the second clip, you'll notice that I've squeezed or have constricted the hose, causing the water to speed up. This is exactly what happens in the Irish Sea, where the water is squeezed up along the coast between Ireland and the United Kingdom, forming a current that flows at very high speed. On the flooding or incoming tide, this flows north, racing up along the Irish beaches. On the ebb or outgoing tide, the exact opposite happens. Again, that squeeze causes the tide to flow very fast, flowing south on the outgoing tide. Don't forget that the size of the tide also affects the speed and ferocity that these currents run at. A neap tide has a smaller variance in height and runs at a slower speed, whereas a spring tide has a much greater variance in height and will run at much higher speeds through the Irish Sea. Maybe a little bit of information overload there, but what does this mean for you when you are swimming on the East Coast? Let's say you're going to go for a swim on Greystones Beach. You decide you're going to swim at the north end and go south. Now let's pretend the tide is going out and is also flowing south. When you go to swim back up against that tide, you're going to find yourself in an unfavourable situation. Whereas if you started at the south end of the beach and swim north, yes, you're swimming against the tide for the first bit, but as you make that return journey, the tide is going to be in your favour, which is a much better situation. What are the key points to take away from this? Always check the tide times and the tide heights using an app like Magic Seaweed. I've made a video on this before and you can check it out. It's one of my earlier videos. You should always plan your swims around this, and remember, the bigger the tides, the more energy that will be moving. So that's that. Tidal currents explained. Next week we're going to look at the speed of the tide by looking at the rule of 12ths. See you then.